Welcome back, everybody. Today's video is going to be talking about the rate of change for a function, which, if you're talking about just a straight line, it's just a fancy name for the slope. But it has applications beyond just linear functions and can be used for all other types of functions, which is why this is a fairly important topic. So what is the rate of change? Well, rate of change can be viewed in two situations. It can be viewed as the average over an interval. So if you're producing an amount of something, let's say teddy bears, over one interval to the next, you can determine the average amount that has been produced. From like 8 in the morning to 8 in the night, you can find an average. And you can also find it instantaneous at a point. So you can find the average teddy bears produced an entire day, or you can just look at, let's say, 12 p.m. and see how many are getting produced at that point. So those are the two different ways you can view rate of change. So we're only going to work on the first case for now. Later in the semester, we're going to focus on the second case. In fact, that one's going to be fairly important from then on. Now, when we talk about the first case, we're primarily dealing with the slope between 2 points on a graph. So let's take a look at this example here. Let's say this is your production of teddy bears on any given day. And it's centered at, let's say, noon. So at noon, nobody's working, everybody's on lunch break, so nothing's getting produced. But some people take their breaks early, had to break early, some people had to break late. So let's see how your production is on average for that time, for the change. So we can find the slope between any 2 points on the graph on the right. So if we look between the point 1, 1, which is down here, and 2, 4, we can get a slope of 3. For those of you who don't remember how to do that, you take y2 minus y1, and then divide that by x2 minus x1. So we have 4 minus 1 divided by 2 minus 1. Now, if you want to do that in the calculator, you have to make sure you use parentheses. So let's quit this graph. So we want to do 4 minus 1 divided by 2 minus 1. And that gives us 3. If we look between negative 2, 4 and 1, 1, we get a slope of negative 1. And between negative 2, 4 and 2, 4, we get a slope of 0. Now, those all seem completely arbitrary and have no meaning, right? Well, actually, it does tell you a little bit something. So if this is hours before noon and this is hours after noon, from 1 hour afternoon to 2 hours afternoon, on average, we're increasing production by 3. Well, if we're talking between here and here, 2 hours before noon and 1 hour afternoon, our average change in production is going to be minus 1. And if we're going from here to here, we're not going to have any change in production. So that's one of the ways you can use a rate of change. It can tell you information about our graph and how production is changing. So I have now drawn in lines connecting these points. So using the average rate of change we found before, we can estimate the function that's between these points as a linear function. So you use those 2 points and you use the slope that you found. And that just gives you a nice linear function, which everybody knows a linear function is easier to calculate stuff with than quadratic or anything else out there. So note that the closer together the points are, the better approximation we get between the points. So between negative 2 and 2, you can't really approximate our function using that linear one. What doesn't work that well. Between negative 2 and 1, it's a little bit better. It's about the same as this part here, a little. But between 1 and 2, we can see that between those 2 points, this is a fairly good estimation. And it's a lot easier to estimate using a linear function than a quadratic one. So let's go take a look at one exercise. So here's this graph with these 3 points. So using the graph, I want you to find the average rate of change between each set of points. So between the first point and second point, first point, third point, and second point and third point. So go ahead and pause it and get those 3 together. Should be pretty straightforward. All right, hopefully you have done that. So, and I'm hoping that you get 0.25, negative 0.25, and negative 1.75 as your rates of change. Now, this is all fairly straightforward so far. So let's go ahead and look at a straight numerical example instead of graphical. So if our function is something of the form f of x, so it's some function, we're calling it f. We don't know exactly what it is yet. And we want to find the average rate of change between a and b. We want to use the formula f of b minus f of a divided by b minus a. This should look really familiar considering it's just the x2, x1, the entire regular slope formula. So let's say this is our formula here. So suppose you're monitoring the price of gold, and notice that its price per ounce can be modeled by this function for 7 less than or equal to t less than or equal to 10.5, where, so t is in hours, 7.5 is at 7:30 a.m., and then every t after that corresponds to the hour. So after looking at the graph of the function, find the average rate of change from 8 a.m. to 9:30 a.m. So let's go back to our calculator, clear out the old one. We want 5x squared minus 85x plus 1,762. Enter. Now let's make sure our window's good. So this is from 7 to 10.5. So let's start at 6 and go to 11. Now, don't know how to go from here. So we're adding 1,762. So we probably won't go below 0. Max, let's try 2,000. So we see a little bit of a change there. The scale's probably not that great, but as long as you see a little bit, you're fine. But let's change this to 1,000 now. And we can see a bit more of the curve in the graph. So if we want to find the rate of change between 8 a.m. and 9:30, we'll want to use this formula here. But what's g of 9.5 and g of 8? We can do our trace. So 9.5 gives us $1,405.75, and 8 is $1,402. So we have those two numbers, and 9.5 minus 8 is 1.5. which that's going to give us an average rate of change of $2.50 per hour. All right, units are slightly important, so keep that in mind. And that's the rate of change between 8 a.m. and 9:30 a.m. This rate of change has nothing to do with any other time slot. So here's your next exercise. So the following table shows the U.S. daily imports from Mexico from 2001 to 2009. Pretty straightforward. Compute the average rate of change of imports from 2001 to 2006. So keep in mind, T is in years since 2001, so T equals 1 represents the start of 2001. So go ahead and pause it and try it out. All right, hopefully you've done that. And our TI of 6, because that's 2006, and I of 1 is 2001. So that should give you a rate of change of 0.02. All right, see you in class.